In this video, we're going to take a look at the real number system and how we can classify a number into the most appropriate subgroup of the real number system. In order to understand this, we're going to take a look at a broader example. So let's think of pets. Pets is the most general category you can place things in, but we could get a little more specific with the type of pets that you have. We could talk about fish or dogs or cats. But after that, we could even get more specific. When we look at dogs, we could talk about things like labs and poodles and pit bulls and so on. So we have this big general category of pets, which can be broken down into types of animals, which can be broken down even farther into breeds of certain animals. And that's kind of what we're going to do with the number system here. Instead of thinking about pets, we're going to think about the real numbers. This is our big, broad category. And as we break it down, we're going to start by splitting it into two groups. We're going to say rational numbers and irrational numbers. So these are like our dogs and our cats. Now we're going to take those rational numbers and we're going to break them down even into smaller groups. So we're going to take those rational numbers and narrow it down a little bit and get to the integers. And then we're going to take those integers and narrow it down a little bit and get to the whole numbers. And then we're going to take those whole numbers and narrow it down a little bit even farther and get to the natural numbers. So this kind of works down. The higher you are, the more broad. The lower you are, the more general or the more specific. So the most specific type is the natural numbers, working up to the real numbers, which are the most general. So let's take a look a little bit more at what each of these categories of numbers means. You should have a foldable that you have cut in half. You should have cut out each of those squares on the bottom, so you have three pieces. And you're going to take and stack those three squares on top of each other so that the smallest one's on the top. And you're going to staple them all right in the middle of that rectangle on the top half of the page, so you get something that looks like this. Now for the rest of the video, I'm going to be using a digital form of this and not an actual picture of it, but it looks the same, and you'll be flipping these squares up to write on different things. So let's start right on the front. So this is what you should look like. You should have in front of you. This is your half sheet of paper. Notice that I have my 4 rectangles in the middle. Yours would fold. The first category of numbers, we're going to start with the most specific. That smallest group, it was at the bottom of our list earlier. It's going to be on that smallest square. And that they are the natural numbers. So go ahead and write natural numbers right on the front side, the top side of that smallest square. Now the natural numbers, we're going to take and we're going to fold that square up. So it looks like this. Flip this small square up, and we're going to write the definition of the natural numbers right on the back there. And the natural numbers are the numbers we count by, not including zeros. So if you think something at home you're going to count, maybe you're going to count the number of books on your bookshelf, you would start by counting 1, 2, 3, 4, 5, and so on. You wouldn't start at 0 because we don't think of having 0 things. So once you get that definition written there, go ahead and flip that back down to the front. And right above the natural numbers, where we wrote that earlier, or somewhere on that square, we're going to write some examples. And obviously we can't list every single natural number, but we have a way to write a pattern to show that it keeps going on. So we're going to start with the first number 1, comma 2, comma 3, comma 4, and then we're going to add those 3 dots at the end, and that's going to show us that pattern continues on forever without ending, going to the right or getting bigger. So the natural numbers are our first and most specific category of numbers. Let's get a little more general here. On that next square, we're going to talk about the whole numbers. So on that next little rectangle or square out, in the space there, you're going to write whole numbers. And then what we're going to do is we're going to flip up that natural numbers square again, just like we just did. Okay? And we're going to write in the space, so the space where you're writing this is right below where the natural numbers squares goes. Okay? And the definition of the whole numbers are simply the natural numbers including 0. So we're going to take those counting numbers and we're going to add a 0 to it. So it's going to be 0, 1, 2, 3, 4, 5. And so on. So again, you're writing that directly below where the square that you flipped up is, so that when we push that back down, we don't see the definition. Let's go ahead and get our examples. I'm going to put these on the side over here. Same thing with the pattern. I've got the same exact pattern, except I'm adding 0 to the beginning. 0, 1, 2, 3, 4, and so on. All right, we're going to repeat this again. We're going to move out a little bit more. We've now got all the numbers we count by, and we have 0. So now we need to take it in the other direction. Now we're going to add in some negatives, and our next category of numbers are going to be integers. Right? And integers, to where we're going to put this definition is we're going to flip up the whole numbers rectangle, and we're going to write it right below there, right above where we wrote the word integers, below where the paper above it covered. And the integers are simply all whole numbers and their opposites, including 0. Okay, so our whole numbers were 0, 1, 2, 3, 4, and so on. 0 does not have an opposite, okay? But 1 was a whole number. The opposite of 1 is -1. 2 is a whole number. The opposite of 2 is -2. So we're going to take and we're going to match all of our whole numbers with an opposite on the other side. All the whole numbers and their opposites, which include 0. So obviously this is going to give us positive and negative numbers. So let's go ahead and flip that back down, okay, and put our examples along the side again. So now our pattern is just going to start at both ends and continue on. So we have dot, 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 -5, -4, -3, -2, -1, 0, 1, 2, 3, 4, 5, dot, dot, dot. Those 3 dots on either side of my pattern now show me that it continues on in either direction forever without stopping. All right, our final category of numbers in this section here is going to be the rational numbers. Okay? So once again, we're going to take all 3 of those that we stapled down, and we're going to flip them up. We're going to write this definition right in that empty space where the space that was just covered. Rational numbers are any number that can be written as a fraction of integers. So rational numbers are fractions, okay, but it has to be an integer, so we can't have decimals in our fractions. Fractions, or these rational numbers, can be a whole number. I think if we put any fraction or any number over 1, it's just going to be a whole number. 4 over 1 is a fraction of integers, but we would simply write that as 4. And this sometimes might create a decimal that ends, such as 1/2 becomes the decimal 0.5 that ends. Or it might be a decimal that repeats, such as 1/3, 1 over 3 becomes 0.3333, where the 3 repeats. Rational numbers are both positive or negative. So we could have something like -4 over 1, which would simplify it to -4. Or we might have -2/3, -2 over 3. Still a fraction of integers. So if we flip that back down, this now is the view of our whole graphic organizer. Put some examples of rational numbers on there. These are just some of the examples I came up with. You can put anything you might want. 19 over 27, that's a fraction. 19 is an integer, 27 is an integer, so it makes it a whole or a rational number. 1 is a rational number. Mixed numbers, 4 and 3/4, that's a rational number. -4.7, a decimal that ends, it's a rational number. And obviously 3.2, a positive decimal that ends, is a rational number. So now we have everything over on this side. So we can say, work this out. Natural numbers is the most specific that we can get something. So 1 is a natural number, but it is also a whole number, and 1 is also an integer, and 1 is also a rational number, and 1 is also a real number. Just like we could say that a lab is also a dog, and a lab is also a pet. We can say that 1 is any of these. Now, if we looked at something like -4.7, that only fits into a rational number. Right? So it is a rational number, and everything on here is a real number. So no matter what number you're given, you can always classify it in this class as a real number. So -4.7 is a rational number. -4.7 is a real number, but it is not an integer. And if it's not an integer, it can't be a whole number, and it also can't be a natural number. So this graphic organizer works out, but it doesn't work in. Now we have one more category of numbers over here on the left, and these are things that don't fit into any of our squares. Or rectangles. That's why it's a oval. And these numbers are exactly the opposite of rational numbers. Okay, so if they're not rational, we're going to call them irrational. And the definition is going to be exactly the opposite of a rational number. So rational numbers had to be written as a fraction of integers. Irrational numbers are numbers that cannot be written as a fraction of integers. So typically, and almost all the time, these are going to be numbers that have some meaning that we're not quite sure of. An example that you've all seen is pi. That is a rational or an irrational number. And we can't write that as a fraction. It's 3.14, so on. It never ends. It never repeats. Another example is the square root of 2, and we're going to be taking a look at square roots a little bit later. But the square root of 2 comes out to be 1.4 something, I believe, and that just keeps going on forever without repeating or ending. So these typically, or these always, turn into decimals that never end and never repeats. So now in 10 minutes you've learned about the real number system. Right? Recapping, we have natural numbers are the most specific type of numbers. They're the numbers we count by. Moving out and getting a little more general, we have whole numbers. We're adding the 0 to those natural numbers. If I go out a little bit farther, I get to the integers, and I take all those whole numbers and I add their opposites, which are the negatives. Getting the most general I can in this category, I get the rational numbers, which is anything that can be written as a fraction of integers. And all of those numbers are real numbers. On the other side, if it doesn't fit into any of those categories we just talked about, it's an irrational number. It cannot be written as a fraction of integers. The decimal ends or repeats, but those are also considered real numbers.